Today we discuss about the topic application of integration. That is verify Green's theorem. The statement of Green's theorem is integral over C u dx plus v dy equal to double integral over here over R dou v by dou x minus dou u by dou y into dx dy. That is we can find some area of the given region. The area is equal to sum of the length of the outer line of the region. For example, you can find some area like that. Find this area. This area is equal to sum of the outer line. This line plus this line plus this line. The area equals sum of this outer line. This is the statement of Green's theorem. So now we can verify the Green's theorem for the given problem. Integral over C 3x minus 8y square into dx plus 4y minus 6xy into dy. First we can find the value of u and v. So given u equal to 3x minus 8y square and v equal to, it is u dx plus v dy. Okay. So u is 3x minus 8y square and v equal to 4y minus 6xy. So now find the value of dou v by dou x. So dou v by dou x is the differentiate the function v with respect to x. So first one is there is no x term, this is constant term, the value is 0 minus, second one is 6y is equal to minus 6y. Next one is dou u by dou y. That is differentiate the function u with respect to y. So first one is there is no y term, that is 0 minus 16y. So these are next we can find write the statement of Green's theorem, that is integral over C u dx plus v dy is equal to double integral over R dou v by dou x minus dou u by dou y into dx dy. Verify right hand side value and left hand side. Find the right hand side and left hand side. These two values are equal. The right hand side term is integral over R dou v by dou x minus dou u by dou y into dx dy. So next we can find the limit of the given region. The given region is x equal to 0, y equal to 0 and x plus y equal to 1. You can draw the line. Draw the x axis and y axis. This is x, this is y axis. So x equal to 0 is nothing but it's a line for y axis. This is x equal to 0. This one is y equal to 0. Next x plus y equal to 1. This is straight line. In graph we need minimum 2 points for the draw the straight line. So first we can find the 2 points, x plus y equal to 1. First assume that x equal to 0, then y equal to 1. Similarly y equal to 0, which implies x equal to 1. But the points are 0, 1. 0, 1 is here. X equal to 0, y equal to 1. This is 0, 1. This is 1, 0. So draw the 2 points. So this is the required region. Okay. We can find the area for the region. Therefore, the limit, find the limit and limit of x and right to left. That is 0 to this. This is the equation of x plus y equal to 1. Therefore, y equal to x equal to 1 minus y. Therefore, the limit of x varies from 0 to 1 minus y and y varies from bottom to top. It is 0 to 1. So next apply the integration for the equation. Next the value of integral over R dou v by dou x. Dou v by dou x is minus 6y and dou u by dou y is minus 16y. Minus of minus 16y into dx dy. So x is inner limit, y is outer limit. The limit of x is 0 to 1 minus 1. Integral 0 to 1 minus 1 this is outer limit. This is 0 to 1 minus y. This value is 10y. 6y plus 16y is 10y dx dy. The x is inner limit, the value is 0 to 1 minus y, and y is outer limit, the value is 0 to 1. So indirectly this is integral 0 to 1, integral 0 to 1 minus y, 10y dx dy. So first inner limit is x, differentiate the function with respect to x. Integral 0 to 1, differentiate the function 10y with respect to x, that is 10y is constant, and integral of dx is x. The limit is 0 to 1 minus y into dy. Integral 0 to 1, 10y, apply the limits. Upper limit is 1 minus y minus 0 into dy. Integral 0 to 1, multiply the 10y. 10y minus 10y square into dy. So next integrate the function with respect to y. So first one is 10y squared by 2 minus 10y power 3 by 3. The limit is 0 to 1. Apply the upper limit, that is 10 by 2 minus 10 by 3 minus 0. 5 minus 10 by 3. Take LCM. 15 minus 10 by 3 equal to 5 by 3. This is the area of the given region. This is the left hand side. Next we can find the value of right hand side. The right hand side is integral over c u dx plus v dy. That is the statement of Green's theorem means this area is equal to sum of the line, that is this point is O, this point is A, this point is B. The sum of the line OA and the sum of the line AB and the sum of the length of the line is BO. This value is equal to integral OA plus integral AB plus integral BO. Integral OA is first one. In integral OA is, in OA the line x y equal to 0. This is the y equal 0. OA is y equal 0 and x varies from 0 to 1. In OA, y equal to 0 and x varies from 0 to 1. Therefore, the integration is equal to integral u dx. It is 3x minus 8y square into dx plus 4y minus 6xy into dy. So in this equation we apply y equal 0 and also dy equal to 0. The limit is 0 to 1, 3x minus 0, that is y is 0, 3x minus 0 into dx. Second term fully 0, that is because dy term is 0 plus 0. By integral 0 to 1, 3x into dx. Integrate the 3x squared by 2, the limit is 0 to 1, the value is 3 by 2. Similarly, we can find integral AB and integral AB. Finally, we get the sum of the integral OA plus integral AB plus integral BO equal to 5 by 3. Therefore, left hand side equal to right hand side, hence Green's theorem is verified. Okay, thank you.